Shirul. The water is so clear that in winter you can see 30 meters straight down into it. Not 30 feet, 30 meters. And beneath that window of visibility, the lake keeps going, down past the reach of any diver, past the point where light disappears entirely, all the way to a floor that sits more than a kilometer below sea level. This is not a poetic exaggeration. It is a surveyed measurement, and it raises the question that has shaped every scientific expedition to this place for more than a century. What exactly is happening inside a body of water this old, this deep, and this alive? Lake Baikal sits in southern Siberia, pressed between Irkutsk Oblast to the northwest and the Republic of Buryat to the southeast. It is 636 kilometers long and 79 kilometers wide, slightly larger than the country of Belgium. But surface area is not what makes Baikal anomalous. Maximum depth is 1,642 meters. Volume is 23,715 cubic kilometers of fresh water, which accounts for roughly 22 to 23% of all fresh surface water on Earth, more than all of the North American Great Lakes combined. The lake is not simply large, it is singular. UNESCO recognized that singularity in 1996, designating Baikal a World Heritage Site. The lake formed in a rift valley created by the Baikal Rift Zone, where the Earth's crust is slowly pulling apart. That process is still underway. The rift widens approximately 4 millimeters per year. The fault zone remains seismically active, with notable earthquakes occurring every few years and hot springs distributed across the area. Below the lake floor lies approximately 7 kilometers of accumulated sediment, placing the rift floor somewhere between 8 and 11 kilometers beneath the water's surface, the deepest continental rift on Earth. The age estimate is 25 to 30 million years, making Baikal the oldest lake in geological history. Most lakes of comparable size were scoured clean by continental ice sheets during glaciation events. Baikal was not. Its sediment record survived intact. And when Russian, American, and Japanese researchers conducted cooperative deep drilling core studies in the 1990s, they recovered a detailed climatic record extending 6.7 million years into the past. The sediment still holds more. Longer and deeper cores are expected to extend that record further. This is the pattern interrupt. The lake did not simply survive the ice ages, it documented them. While glaciers destroyed the sediment archives of comparable lakes worldwide, Baikal's unusual position and depth preserved a continuous record of planetary climate that exists nowhere else on Earth. What was expected to be a regional geological feature turned out to be a planetary archive. Baikal is home to thousands of species of plants and animals, many of them endemic, found nowhere else in the world. The lake is rich in oxygen, even at its deepest points, which separates it from most stratified bodies of water of comparable depth. That oxygenation at depth is itself scientifically unusual, and the mechanism sustaining it across all three of Baikal's basins, the northern basin reaching approximately 900 meters, the central basin reaching 1,600 meters, and the southern basin reaching 1,400 meters, remains an active subject of study. The basins are separated by fault-controlled accommodation zones, with Academician Ridge dividing the north and central sections, and the Selenga Delta region marking the boundary between the central and southern sections. Up to 330 rivers feed into the lake. A single river drains it, the Angra, a tributary of the Yenisei. That asymmetry, 330 inputs, one output, is part of what makes the lake's water chemistry so stable and so clear. Winter transparency reaching 30 to 40 meters is a documented measurement, not an approximation. Summer transparency drops to between 5 and 8 meters, driven by seasonal biological activity. Baikal is also the only confined freshwater lake on Earth, where both direct and indirect evidence of gas hydrates has been documented. Gas hydrates, methane and other gases trapped in ice-like crystalline structures under conditions of high pressure and low temperature, exist at the lake floor. Their presence connects Baikal's geology to questions about carbon cycling, deep water chemistry, and the long-term stability of the lake bed. What role those hydrates play in the lake's overall chemistry and what their fate might be as temperatures change is not resolved. Two competing interpretations frame the ongoing scientific debate. The first holds that Baikal's isolation, depth, and age created conditions so stable that endemic species and unique chemical properties evolved undisturbed across geological timescales. That the lake is, in essence, a natural laboratory sealed off from the disruptions that reset other lakes. The second holds that the same rift dynamics that created the lake's depth also make it fundamentally unstable over geological time. That the 4-millimeter annual widening, the seismic activity, the gas hydrates at the floor, and the hot springs around the basin are signs of an ongoing transformation whose endpoint is not predictable from the current record. The evidence supports elements of both. The sediment core data demonstrates long-term stability over millions of years. The seismic record and the active rift widening demonstrate ongoing change. Neither interpretation is wrong. They describe different timescales. And the honest answer, supported by the record, is that both processes are operating simultaneously, which means the lake's future does not follow simply from its past. What Baikal reveals at scale is a problem in how lakes are understood. Most limnology, the science of inland waters, is built on studies of lakes that are geologically young, comparatively shallow, and hydrologically simple. Baikal violates all three assumptions. Its age means that evolutionary processes have had tens of millions of years to produce organisms adapted specifically to its chemistry. Its depth means that conditions at the floor are essentially disconnected from surface conditions. Its rift origin means that the basin itself is still being shaped by forces that predate the lake. The tools developed for ordinary lakes apply imperfectly here, and the data from Baikal does not always fit the existing frameworks. That mismatch is not a failure of the science. It is a finding. The Buryat people have lived on the eastern shore of the lake within Buryat for generations, raising cattle, horses, sheep, goats, and camels in a climate that swings from a winter minimum of -19 degrees Celsius to a summer maximum of 14 degrees Celsius. The lake and the communities around it are not a remote abstraction. They exist within a living cultural and ecological system whose continuity depends on conditions that researchers are still working to understand. The 27 islands, the surrounding Baikal Mountains and Barguzin and Primorsky Ranges, the protected national park across the mountainous taiga, all of it is contained within a rift that is measurably, actively widening. Return to that winter image. 30 to 40 meters of visibility through liquids so cold and so oxygenated that it supports life at depths where most lakes hold only still, anoxic darkness. Below the visible zone, the water continues downward through 1,600 meters of the central basin, past documented gas hydrate deposits, past the reach of the 1990s drill cores, toward a sediment column 7 kilometers thick that holds a climatic record still only partially read. The lake is 25 to 30 million years old. It is still widening. Its deepest chemistry is still being mapped. Its endemic species are still being cataloged. The precise unresolved question is not what Baikal contains. It is what the continuous, active widening of the rift means for the stability of everything the lake has preserved. The Sediment Archive, the endemic biology, the gas hydrate deposits, across the next geological interval. The record shows the lake survived every disruption for 25 million years. It does not show whether the current rate of change falls within the range of what the lake has survived before or outside it. That question has no current answer. The unsolved vault. Every case leaves something behind.